guys, I figured since I have to make a key for this anyway, why not record myself making the key and post it up for you guys, and I'll try to explain as much as I can without this taking so long that it becomes too long of a video to watch. Okay, here we go. This equation can be written as, I look at these, looks like they've solved for y in every case. So this is gonna be what I would get if I took the base of the log, which is x plus 1, and I did to the power of, I made everything on each side the exponent of that. That would allow this and this to cancel out, and I would get x plus 1 squared equals y plus 1. And now to isolate y, I just have to subtract the 1 from both sides. I'm switching these two to write y equals x plus 1 squared minus 1. That one. Okay. This expression can be written as, ooh, this looks like a good old combining log situation. Each log has the same base. The base is 10. So I'm going to write it as one giant log, and every log that's positive is going to be on the numerator, and every log that's negative will be in the denominator. Had I had coefficients, I'd move them up, but I didn't. So this is 2x on top, 2 and x, both positive, and then x plus 3 on the bottom. There it is. Okay, 3 to the x equals 4. I gotta solve this guy. What I can do, since the base of my exponent is 3, is I can log base 3 both sides. It will allow me to get rid of that, to get that x equals log base 3 of 4. Okay, let's keep it going. This is just like that previous problem, except there's this 2 here, and that 2 is not welcome. We're going to first divide it from both sides. So I get 5 to the x plus 2 equals 7 over 2. And now all I got to do is log with this base on both sides. I get x plus 2 equals log base 5 of 7 over 2. And if I just subtract that 2 from both sides, I get x equals log base 5 of 7 over 2 minus 2. You may be uncomfortable with this, but this is a constant. This is an answer. This is just a number. If you chose to ln or log both sides, whether this problem or this problem, you wouldn't have gotten one that was these exact form. But you could have done change of base formula with these to get a decimal approximation and match it to the one that you got. Okay, keeping this going. Solve this log equation. I want a maximum of 1 log on each side. So first, I'm gonna combine some logs. I'm not explaining it in detail. If you need the explanation, go back to number 2 where I explained it. As to why this turned into this. And now I'm going to go 3 to the power of on both sides. Boop. X over 2 equals, oh my gosh, this cancels too, 7. Multiply both sides by 2. X equals 14. I do have to go back to the original and make sure that I'm not putting any negative numbers or zeros inside logs by plugging in 14 for x, and I'm not, so this is fine. Okay, same here. I combine these. Log base 2 of x times x plus 2 equals 3. I go 2 to the power of on both sides. These cancel, so I get x times x plus 2 equals, careful here, this is not 2 times 3, this is 2 to the power of 3, which is 8. And then here I must distribute x squared plus 2x equals 8. The only way I can solve a quadratic like this is to move everybody to one side and set it equal to 0. At which point I try to factor. Can I find two numbers that multiply to -8 but add to 2? I sure can. Oh no, that's a lie. How did I get 6 and 2? I meant 4 and 2. So 4 times -2 is -8. 4 minus 2 is 2. That makes x plus 4. X minus 2 equal to 0, which makes x equal to -4 or positive 2. I do have to come up here though and check them out. And uh-oh, can't plug in a -4 there or there. This guy's out. 2 is my only solution. X equals 2. Okay. And here we go. Combine. Let's do this. Coefficients go up. So step 1, this is log of a to the 4th power minus log of b to the 1/2 power plus log of c. And now let's combine. One big log. If your log is positive, you go in the numerator. If your log is negative, you go in the denominator. This guy's log is positive, he goes in the numerator. So then we check. Who's got this situation going on? A to the 4, C on top. This one does. None of the rest do. But I'm a little thrown off. There's a square root of b on the bottom, and I have b to the 1/2. If only these were the same thing. Oh, wait a minute. They totally are. We're good. We're totally good. This is the answer. Okay? Okay, I'm going to stop the video here so that the multiple choice can have its own video, and then I'll do the rest on another one.